Alright everyone, today we are going to start with the chapter metals and non-metals. We're going to do a quick revision for standard 8th, 9th and 10th. Alright. Okay, metals and non-metals. So basically the first question which stands in our mind, which pops in our mind is what are metals and what are non-metals. But before moving ahead with this, we should know what are the three types of elements. Okay, and metals and non-metals come under what category? We will be dealing with that. So see here. Basically, all the substances, or you say simple words, matter. Matter is classified into two types. Pure matter and impure matter. This is the classification of matter. Okay, all of us know what is matter. Matter is a substance which has got some mass and some volume. So now pure matter is again classified into elements and compounds. Elements and compounds. And talking about impure matter, so impure matter into mixture. Okay. Now again, the element is classified into three types: metal, non-metal and metalloid. This is the thing we are learning here, okay? And mixture into two types. What are those two types? Homo and heterogeneous. Okay, and again you see heterogeneous into three types: colloid, suspension. Okay, only two types, sorry. Heterogeneous into two types, that's colloid and suspension, and homogeneous into true solution. Right, these are the things we already know. We are just doing a quick revision, right? We know now that matter which was divided into pure matter that consisted of elements and compounds, and those elements consisted of the metals, non-metals and metalloids, which says that elements are classified into the metals, the non-metals and the metalloids. So from there we get metals, non-metals and metalloids. So we know now that metals will consist of the same type of atoms. Similarly, non-metals will also consist of the same type of atoms. And metalloids also of the same type of atoms. Why? Because it's an element. An element is the purest form of a substance. Now, let's come here. So all the objects or materials, they are formed of elements, compounds and their mixtures. Now, I told you that elements are classified into metals, non-metals and metalloids. Now, what are metals? Some examples of metals we already know. We have jewelry is made up of gold, silver, platinum. Then we have iron, we have copper, aluminum, magnesium, calcium, sodium, platinum, right? So many metals are there, right? And what are the properties of a metal? It has got luster, it is hard, it's not brittle, right? We can have wires, we can have sheets which are made up of metals. Metals are good conductors of heat and electricity, and metals, they tend to lose their valence electrons and then they produce positively charged ions. What is the meaning of this sentence? That metals, they can lose their valence electrons to produce positively charged ions or cations. Look here. Let us try understanding it. Yeah. So if I take any metal, let us say I took the metal calcium. Okay. Now calcium's atomic number is 20. Right, and so atomic mass is 40 here. Electronic configuration of calcium, let's do that. So 20 is the atomic number, 2, 8, 8 and 2. Right, we get 2, 8, 8 and 2 as its electronic configuration. Because we have to complete its octet, now it has the ability to lose these 2 electrons. In the valence shell, valence means outermost shell, how many electrons are there? 2 electrons are there. So it can lose these 2 electrons. And then when it loses 2 electrons, it will form a positive charge on it, right? See, calcium, what it will do? It will lose 2 electrons, okay? It will lose 2 electrons. And when it will lose 2 electrons, so it will have a positive charge of 2. because it lost its electron, its negative energy was gone, so positive vibes will come in. So that is why we say calcium has a valency of positive 2. Got it? Similarly, if I take the example, I'll tell you one more example, but it is clear. I'm just talking about metals here. See, now let us take which metal to take? Boron. No, boron not. Boron is a non-metal, right? Bromium is a non-metal, sorry. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium. Sodium, let's take sodium, okay? Sodium, number is 11. Mass is 23. So, now it has in electronic configuration 2, then 8. 8 plus 2 is 10 now. And how many is left? 11 minus 10, 1 more left. So, it has now the ability to lose this 1 electron. So, what it will do? It will lose 1 electron. When it will lose 1 electron, so it will have a positive charge of plus 1 on it. Okay, this is how we find out now valency will be 1 because in the outermost valence shell it has got 1 electron. This is how we are doing the electronic configuration we are finding out. So that's why what we can infer about the metals, that they are electropositive in nature. Electropositive in nature because they have the ability to lose electrons and have a positive charge on them. Alright, coming back. Yeah, positive charged ions, they are called as cations. They are the positively charged ions, and negatively one, they are called the anions. Now let us talk about the physical property of metal. So first the physical state. So always and always, most often metals are found in solid state. However, if we talk about metals like mercury and gallium, they are exceptions. Mercury was an exception. Now gallium is also there, just slightly below room temperature. They exist in liquid state even at the room temperature. Now, yeah, this is, can you recall one? Let's do this. You must have seen a doctor's pressure gauge, right? With which he measures the blood pressure. So it has got a grey colored liquid in glass tube, and which is that metal? So that is actually mercury. Hg is the metal which is used. And in thermometers, what metal is used? In laboratory thermometers in the bulb, in that we used alcohol. Okay, alcohol is used in laboratory thermometer. Previously mercury was used, but it's poisonous. That's why we use alcohol. Now let's talk about luster. So we see that metals, they have a unique luster on them, right? They are very shiny. Now if we see copper vessels, so we scrub them with lemon and then we rinse them with water. Why do we do that? Why? I mean, like, why does that luster come back after just rinsing it with that thing? So that is because basically what does lemon consist of? Citric acid. So that citric acid, it combines with that copper and a reaction takes place which forms copper carbonate. Okay, copper carbonate is formed, and that is why the luster is maintained here. A layer of copper carbonate is formed. Now, hardness, so generally metals are hard, but the exceptions are sodium, potassium. More exceptions are there. Calcium is there, lithium is there, okay, gallium is there. More examples are there. So basically, like, yeah, cesium is there. Cesium, gallium, lithium, calcium, all these are also included in here. Okay, hardness, about hardness, mercury is also there. Alright, now talking about ductility. So ductility is the property of a metal to be drawn into thin wires without breaking, and metal has so much ductility. The highest ductility is in gold. Okay, Au, gold, it has the highest ductility. Malleability, so malleability is the ability to be beaten into thin sheets without breaking, and the highest malleability is in aluminium and silver. Aluminium and silver. Gold is also there. Now conduction of heat. So silver is the best conductor of heat. After that copper comes and aluminium comes. It can let heat pass through it. And about electricity. So metals are good conductors of electricity. But exception here is lead. Lead or lead, that is Pb. This is an exception because it is not neither a good conductor of electricity nor a good conductor of heat. So lead is an exception here. Talking about the density, so generally the metals have high density, but again sodium, potassium, lithium, they are exceptions. Lithium has a density of 0.53 gram per centimeter cube. So you can see the density here is very low, right? And the highest density you see is in solids, right? That's metals only. Sodium is also an exception, potassium is an exception, but lithium, you see, it's very down. Now melting and boiling point. So generally metals have high melting points and boiling points. The highest melting point is in tungsten metal. Tungsten has highest melting point 3422 degrees Celsius. So tungsten has the highest melting point. Now exceptions are also there again. Mercury, gallium, sodium, potassium, these all are exceptions. Sonority means when we are striking it, so it will produce some sound. Metals are sonorous. Now talking about non-metals. So again, some examples, let's say carbon, sulfur, phosphorus, they are few non-metals and they are brittle and non-lustrous. Now they are electronegative in nature, which means, I'll tell you here. We talked about how electropositive we can say metals. Now let's talk about how non-metals are electronegative in nature. They can form anions, which means negative charges on them. Let's take an example. Let's take carbon here. Okay, carbon 6 is there now, atomic number. This is 12. Isotopes are also there, but we'll just see here. 6. So what will be the configuration? 2 and 5, 4, right? So in the valence shell, carbon has got 4 electrons. So valency is 4. Now what will happen? It will have a valency. It will have the tendency that it can lose 4 electrons. Correct? It can lose 4 electrons. It can gain 4. It can gain 4 electrons, right? So we'll have a charge of plus minus 4. Because it can gain also, it can lose also. Exception, I'm telling you. Let me give you a very clear example for it to be understood. Let us take the example of nitrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. Okay, let's take nitrogen, right? 7. It has 7 now. 1 minute. Let's take nitrogen. Nitrogen 7, 14. So 7, I can break it into 2 and 5. Now you see it has 5 electrons in its valence shell. What it can do? It can gain 3 electrons now. It can gain 3 electrons to complete its octet, right? So what it will do, nitrogen, it will gain 3 electrons. When it will gain 3 electrons, so it will have a positive charge of plus 3 on it. Plus 3 on it. Got it? So what happened was, we had the atomic number, we did its electronic configuration, we saw that it needed 3 more electrons to complete its octet, or means 8 electron shell, and so it had a positive charge of 3 on it. That's its valency. Now, physical state, the most often the non-metals are solids and gaseous in nature. Bromine is the only liquid one. Okay, luster, so they do not have luster, except diamond is an exception. Iodine crystals are exceptions. Generally, you see non-metals are colorless. But if I talk about carbon, carbon is blackish in color. Sulfur is yellow in color. Bromine is brown in color. Brittleness, so brittleness means that some non-metals, they are soft, they have the ability to break, right? But if I talk about diamond, which is the allotrope of carbon, it's an exception. It is the hardest natural substance. Ductility and malleability, so non-metals, they are neither ductile nor they are malleable. Okay, conduction of heat and electricity, so then again we have this conduction of heat. So diamond is a good conductor of heat, it's an exception, okay, and graphite is a good conductor of electricity. Alright, density, so generally the non-metals have low densities. Melting and boiling point, so generally we see that non-metals have low melting point and boiling point. But if I talk about exceptions, so we have carbon and boron. Carbon and boron, they can melt at a high temperature. Okay, carbon and boron. Now some points to remember we have. Look. Gold, silver, aluminium, they are highly malleable. Gold is the most malleable one and gold is the most ductile one also. A sheet with thickness 1 by 10,000 millimeter and a wire with diameter 1 by 5,000 millimeter can be made from gold. It's telling, we can break it into so large, like, so small, so large, diameter can so large, diameter can be so small. It can be only possible with gold because it's highest malleable and highest ductile also. Highly. Okay. Metalloids are intermediate. They have the properties of metals also, they have the properties of non-metals also. And some of the examples are arsenic, silicon, germanium, antimony. Electronic configuration I've told you. Now see, generally we are talking about metals, they can have at most 3 electrons in their valence shell. Okay, at most 3 electrons in their valence shell. And formation of ions, you already know, no? Metals, they can lose their valence electrons, they can form cations, and then they can just donate and receive and all that, and thus they can form ions. Now, reaction with oxygen. So when metal reacts with oxygen, it forms metallic oxides, and these are basic in nature. Okay, and now when I react those metallic oxides with acid, it will form salt plus water. And when I react a metal with acid, so I will get a salt plus hydrogen. Okay, I'll get a salt plus hydrogen. Now reaction with water. So mostly they do not react with cold water. Okay, but if I take sodium and potassium, they highly, vigorously they react with cold water. They produce hydroxides, they produce hydrogen gas. But there are some metals like the magnesium. Magnesium is there. It requires steam. It requires steam to do some similar reactions. Non-metals, so non-metals can have 4 to 7 electrons in their valence shell, and they can accept electrons, they can form anions, as I already told you all. Now reaction with oxygen. So non-metals react with oxygen to form oxides, and they are non-metallic oxides which are acidic in nature. And now these non-metallic oxides, when they react with when they react, these oxides, when they react with bases, okay, when I make them react with bases, they will form salt, which is soluble, and they will form water. Okay, now when these the oxides, these non-metallic oxides, when I make them react with water, so they form acids. Okay, similarly, if I make them react, make metallic oxides react with water, they will form, mostly they will form bases. And here you need to remember, non-metal reacts with oxygen to form non-metallic oxides. Non-metallic oxides then react with bases to form salt and water. Okay, similarly, what did metallic oxides do? They reacted with acids and they formed salt and water. Here non-metallic oxides, they will react with bases, they will form salt and water. And these non-metallic oxides, they can react with water and they can form acids. Alright, and to be remembered that non-metals, they do not react with acids. Similarly, the metals do not react with bases mostly. Okay, now coming here, we have uses. Now before dealing with that, let's know about noble metal. So metals like gold, silver, platinum, palladium, rhodium, they are noble metals. Okay, they occur in nature in their elemental form. If I talk about 24 karat gold, that is gold with 100% pure gold. Okay, that is very soft, they can break, they can bend due to pressure. That's why we mix some amounts of copper, we mix some amounts of silver while making ornaments. So they are made from 22 karat gold. Okay, uses of non-metals, noble metals. So we see that gold, silver, platinum, they are used to prepare ornaments. Now silver has got some antibacterial property, so it is also used in medicines. And gold and silver, they are used for metals, for electronic devices, and catalysts. So platinum and palladium, they are used as catalyst. Now purity of gold, look here. So I told you that 100% gold, 24 karat, it's very soft, it can break due to pressure. So some amount of copper and silver is added. Okay, and to prepare ornaments, 22 karat gold is used. 22 karat gold, it consists of 91.66% of gold. If I talk about 10 karat gold, consists only of 41% amount. 12 karat gold, 50%. Okay, 50% is in 12 karat gold. 14 I increase it to 58. 18 karat gold, so it's about 75. Remember in the series, okay, 10, 12, 14, 18, 22, 24. 6 things are there. Because in the exams it's mostly asked. If 10 carat gold, so it will consist of 41 about. If 12 is there, so it will consist of 50% of gold. If 14 carat gold is there, so about 58%. And if 18 is there, so 75. 22 is there, so 91. That's it. Now let's talk about corrosion. So the gases in the air, they react with metals in presence of moisture. Moisture means hydrogen plus oxygen. H2O, okay, plus one more. That's H2O plus oxygen, that is moisture. Water will be there, oxygen will be there. Okay, so metals, they get affected by this and then they cause corrosion. There's an instance like the Statue of Liberty, which is in New York, in America. Originally it was made up of copper, which means originally it was brownish in color. Okay, now it has turned green because it reacted with the carbon dioxide and moisture and it formed a green colored coating, that's copper carbonate. Okay, it formed a green colored coating, copper carbonate. Now, in iron, a reddish colored deposit is formed, that's rust, Fe2O3 dot XH2O. This is rust. Copper carbonate is CuCO3. And a blackish color, that is silver sulfide Ag2S. Yeah, Ag2S layer is formed on silver, that is blackish in color. Fe2O3.XH2O reddish in color. CuCO3 greenish deposit. Okay. Many methods are also used, like galvanization is used, electroplating is used. Okay, parturition is used. Different methods are used to this prevent corrosion. Alloy, yeah, alloy is also there. Amalgamization. Okay, amalgamization. It's alloy formation. It's a homogeneous mixture of two or more metals in a homogeneous way. That's alloy. They are made by mixing the constituent elements as per the requirement. For example, stainless steel, it consists of carbon, it consists of chromium, it consists of iron. Okay, and nickel also. Like bronze, it consists of copper and tin. Alright, and brass is there, copper and zinc. Now, this one. So there is an iron pillar, that's the Ashokan pillar in the premises of Qutub Minar, and it's even lustrous for now also because it is made up of an alloy. It consists of carbon, silicon, phosphorus mixed with iron. Now, sometimes we see a cheap variety of stainless steel which is sold in the market. It consists of copper instead of the nickel, and that is why we see vertical cracks on our stainless steel vessels. That's the reason. Now, I don't think I have something new over here. Let me see. Okay, why does this happen? This a reason. So stainless steel vessels in the kitchen, they have copper coating at the bottom. Why is it so? Because copper coating is there because copper is a metal, right? And when we heat that container, so copper will help in the easy cooking of the food. Okay, it will help in the easy cooking of the food. That's the reason. And sometimes you see, vessels, they have a coating of tin at the bottom that we call as kalhai. Okay, that is done because sometimes a greenish color deposits copper carbonate and that is poisonous to our food. That is why a temporary coating of tin is done that we call as kalhai or tinning. These were some points I had to discuss. So I hope I'm clear with this metals and non-metals, right? So see you all in the next part. Actually, metals and non-metals is complete, so not the next part, but in the next chapter we're going to deal with. Okay. All right, everyone. Thank you.